Hi there, welcome to my channel Mandu to Fundu. In this video, I am going to discuss about the solution for constructing a binary tree from the preorder and inorder traversal output. Let's look at the problem description. We are given two integer arrays. One is preorder, which contains the preorder traversal output of the tree, and the inorder, which contains the inorder traversal output of the tree. Using these two arrays, we have to build a binary tree and return the root of that binary tree. Constraints are the array length is ranging from 1 to 3000 and both inorder length and preorder output length is same, and the values are ranging from -3000 to 3000, and also each element in the preorder and inorder array is unique. So if you see, there is no duplicates. Let's look at the approach to build the binary tree from this input. How we can use these two input array to determine the structure of the tree. First, we take the preorder output. So when we traverse this output, whenever we visit an element, all the elements following that particular element are either its children or siblings. Okay. For example, let's take the case of 3. It is the oldest ancestor in the entire tree. And 9 and 20 are following 3, so they are children. 15 and 7 are following 20, they are children of 20. Even the 20 is following 9, it is not children, but instead it is a sibling. So the idea is whichever element comes first, that is the either parent or grandparent of the elements which are following. With this inorder traversal output, we can compute the left subtree size. For example, in the case of 3, we look up that value in the inorder traversal output and find the index as 1, and when we subtract the starting point of that inorder traversal output, we get 1 minus 0, 1, which is the number of elements in its left subtree. So for 3, only one element is present on the left subtree. First thing what we do is we build a hash map for this input, inorder input data. That hash map contains this value and its index, because whenever we traverse the preorder, we want to find the index of this node. So we can quickly, in order of one operations, we can find that index value if we have the hash map. Okay. Then we call the helper function, which takes the starting point of the preorder traversal and ending index. Same way for the inorder starting and ending, and pick up the first element in that preorder output and look up the index in the hash map, then compute the left subtree size, and then make a recursive call to process the left subtree of this root and the right subtree of this root 3. So if we keep doing that recursively, finally we build a binary tree. Let's look at the flowchart. Input for this procedure is preorder output array and inorder output array, and then the starting position of the preorder array and current ending position, and then starting position of the inorder and ending position of the inorder output array, and then the hash map, inorder outputs hash map, which contains the value and the index in which it is present in the inorder output array. Okay. First we initialize the root. Next we check whether we process the entire array, like if the starting pointer of the preorder output array is greater than the ending point, that means we completely traverse that preorder output array. So we come out and return the root. Otherwise, we create the root node with that first element pointed by the pointer POS, preorder start, and we build the root node and then find the root node's position in the Inorder Traversal output array. Okay, and assign that index to a variable root idx. Then we compute the size of the left subtree of the current root node, subtracting the current Inorder start pointer from the root idx will give number of elements in the left subtree of the current root node. Now we've created the root node. Now we have to create the children node. For that we have to make the recursive call and we have to pass the appropriate portion of the preorder and Inorder output array. For example, we make a recursive call to build the left child. We have to make the recursive call with the preorder array and Inorder array. Because root node is present in the location pointed by POS, we skip that. So POS plus 1 is the starting pointer in the preorder and then POS plus left count is the last index of the left subtree of the current root node. Same way the IOS is the Inorder start and the root IDX we have to skip. So the root IDX minus 1 is the last element in the left subtree. And then we pass the Inorder hash map to that call. So when it returns, that return value is the root of the left subtree. So we assign that return value to the current roots dot left. Same way we make a recursive call to process the part of the array which contains the right subtree of the current root node. For that we pass preorder and Inorder as it is, but the left subtree is starting from POS plus left count plus 1th index and all the way till the preorder end index. Then in the Inorder output it will be starting from root idx plus 1 all the way to Inorder end pointer, and then we have to pass the Inorder hash map for lookup. So when it returns the root node of the right subtree. So that will be assigned as the right child to the current root node. So we do this recursively until all the elements in the array is processed. Finally we return the root of the binary tree. Let's move on to coding. First I create the Inorder map which contains the values in the Inorder traversal array and its corresponding index. So I iterate over that Inorder array and then build that map. Next I make a call to the helper function. So this actually takes the preorder array and its starting index and ending index, then the hash map that we built, then the Inorder Traversal array, and then the starting and ending index of that array. So as we make further recursive call, we will adjust the starting and ending index accordingly. Next I am going to write the helper function. And this function returns the pointer to a tree node. First I check whether the preorder start index is greater than preorder end index, in that case I return because we processed all the elements in the preorder array. Otherwise I read the current root present at the location pointed by the preorder start index. So and then I'm finding the position of that value in the Inorder Traversal array, so which will be assigned to the root IDX. Then I compute the number of nodes in the left subtree by subtracting the Inorder start index from the root index. Then I construct the root node with the value pointed by the preorder start index. I think for better readability I assign that in a variable and use that. It will be easier. Next I make a recursive call to this helper function to build the left subtree for this root node. So for that I have to pass an appropriate start and end indexes from the preorder and inorder array such that they contains only that part of the trees nodes. For example, in the case of while building the left subtree, I have to pass the index starting and ending index which contains the left subtree nodes. So in the preorder array, the left subtree is present from POS plus 1 till POS plus left count. So the inorder array contains the left subtree starting from index IOS till root IDX minus 1. So that's why I am passing that value as the index range. Similarly, I make a call to build the right subtree where I am passing that same preorder and inorder arrays and stuff, but the starting index will be POS plus left count plus 1. And the end index will be the preorder end index. Then I pass the inorder map and inorder array, and then index root IDX plus 1 as a starting index in the inorder array, and inorder end index is the last index. So when the control returns, the returned value is assigned as the right child and we return the root node. Next I am going to run the test cases. All the tests passed. Next I am going to submit this program. Cool. The program is accepted. Next I am going to do the code walkthrough with sample input. We have the preorder and inorder traversal output array. The expected output is this tree, which is represented as an array 3, 9, 20, null, null, 15, 7. When we call the build tree function, the first thing we do is create a hash map which contains the value in the inorder traversal array and the corresponding index. This hash map will be used to look up the root node's index in the Inorder Traversal output array. Okay, then we make a call. Then we make a call to that helper function, which takes the preorder traversal array and the starting position, which is the index 0, and the last element's index, and then the in-order hash map, and then in-order array, and the first element in the in-order array and the last element index for that in-order array. So when we make a call, first thing we check whether the preorder start is greater than preorder end. In this case it is false, so we proceed. First thing what we do is we take the value present at index POS in the preorder array. So in this case, in frame 0, we see 3 is assigned in the val variable, and then we look up that val in the hash map to get the index in the in-order traversal array. So in this case 3's index is 1, so root IDX is 1. Next we compute the left subtree size, which has the 3 as the root. Okay, so in this case root IDX minus IOS, the in-order start. So in-order start is 0, root IDX is 1, so the left count will be 1. So there is only one element in the left subtree. We computed the left count, and then we create the root node and assign the val as its value. Okay, so the val is now 3. When we enter this function call, we have just only this node. But when these two recursive call returns back, at that time we will be having the entire tree, because the recursive call further in turn. So when we call the left, it will create this subtree and then attach it as the left child of 3. And when we call this helper function, this tree will be built and assigned that as a right child of the node 3. Finally we get this tree. When we make the recursive call to create the left subtree, what we do is we pass the preorder array and the in-order array as it is, but we have to adjust the starting and ending pointers for the preorder array and the in-order array. So in this case we already processed the root node, so the remaining part what we have to process, the POS plus 1 just after the root node. So that's why we are passing POS 1, and then we want to process only the elements which will form the left subtree. So for that we have to add POS plus left count. This is for the preorder array. In the case of in-order array, what we have to do is we have to pass the indexes that covers this part. So we are passing the in-order start and then the root IDX index minus 1. Okay, so that's what we are doing here for the call to make the left subtree. Okay, so similarly to make the right subtree, what we do is we make a call with the preorder array and the in-order array and in-order hash map, plus in the preorder array the starting and ending positions will be like, the starting position will be after the left child nodes. We have to start from this node. So for that what we have to do, the current POS, the preorder start plus the left child count plus 1, that will be pointing to the next element after the elements which are forming the left subtree. So in this case it will be 2, left count is 1 and plus 1, and then all the way till the end of the array 2 to 4 for building the right subtree. Okay, and then for the in-order map we will have to start the next element after the root index. So the root index is at 1, so we have to add 1, that forms that makes the index 2. So starting from index 2 to end of the in order array, so which is 4. So 2 to 4. So when this function comes back, it will create a right subtree which contains the 15, 20 and 7, and then we will be assigning that to the right node. When we enter this recursive call, the POS is pointing to 1 and POE is pointing to the same element because the number of elements in the left subtree is 1. Okay, and then in the case of once so we'll have to look up this number in the in order array using the hash map, which gives the root idx 0, and then we subtract the iOS the in order start from the root idx, so which gives the left count 0 because there are no nodes which are part of the left subtree for this node. So that's why at the beginning we have just only one node, and when we return from this function we still have only the node 9. Okay, so this will when this function returns back, the pointer to this to 9 is assigned to the root dot left. Next we make a call to create the right subtree. For that the call will be made with the POS with the value 2 and POE with the value 4. First thing we do is we pick up this value and look up in the hash map and find the root index which is 3, and then the left child count is 3 minus the iOS which is 2. 3 minus 2 is 1, so it has only one left child. Initially create the root node and we make a recursive call with the value, the POS value as 3 and the POE value as 4, and and with the same the preorder array and inorder array hash map, and then we pass iOS pointer value as 2 and IOE to 2. So this will create the node 15. Okay, and then return back, and when it returns back, this node will be attached to the 20. It becomes a left child. Okay, and then next we make a call to process the right subtree of the node 20. So in that case we pass the preorder array and POS as 4, the last element, and we look up this elements in the inorder array which is root idx 4, and we pass the inorder start as 4 and the inorder end as 4. So the number of elements in its left subtree will become 0. Finally we return the same node. So when this function call is returned back, this node will be attached to 20 as the right child. Once this is done, this control will be in frame 1, which returns this node back to the frame 0, and where the 20 will be attached to the right child of 3. Finally we get this entire tree. Next I'm going to do the time and space complexity analysis for this solution. Let's do the time complexity analysis for this input. Okay, so the input array has totally 5 elements. Okay, so in order to build this tree, we have to traverse the entire array, but instead of iteratively, we process that array recursively. Okay, so in any case totally it will be n times. For this input we have to make a call to the helper function 5 times. The time complexity of this solution is order of n. Okay, then the space complexity is also order of n. So if you look at it, we create the hash map. The hash map size is equal to the input array size. So in order, for example, in this case 5 elements are there in the inorder array. So this map also will have an entry for those 5 elements. So for this we have space order of n. In addition to that, we are using stack space because we are making a recursive call. So whenever a new call is made, we create a stack frame. So that space requirement varies depending on the nature of the input. If the tree is complete binary tree, then the maximum number of frames created will be the height of the tree. That is all order of log n. But if it is a skewed tree, then it will be order of n. So this is for the hash map and this is for the stack frame. So combined order of 2 times n. So we are removing the constant out and the space complexity is order of n. Thanks for watching this video. Have a great day.